The topic is about capacitive effects in PN junction diode. We have two types of capacitances, transition capacitance and diffusion capacitance. So transition capacitance happens in the reverse biased PN diode. We know in PN diode in reverse bias the depletion width increases as the reverse bias increases. So at zero reverse bias the depletion width is minimum, and as the reverse bias voltage increases depletion width increases. Considering the P and N side as two parallel plates of the capacitor and the depletion region as the dielectric of the capacitance, C equal to epsilon naught R, epsilon naught epsilon R A by D, where D is the distance between the parallel plates, epsilon naught and epsilon R are permittivity of the dielectric and free space, and A is the area of the plate. So when the distance between the parallel plates, the depletion width increases, the capacitance value reduces. So this capacitance is used in many applications and it is called as transition capacitance. It depends on the applied reverse bias potential. The capacitance is maximum at zero reverse bias voltage, since the distance will be minimum at that time. Cp equal to C of 0 1 by 1 plus Vr by Vk whole power n, where C of 0 is the capacitance under no zero bias. Vr applied reverse bias voltage, Vk is the knee voltage, and N half for alloy junction and 1 by 3 for diffused junction. Typical value of the transition capacitance is 5 to 200 picofarad and it is used in varactor diode. Diffusion capacitance is another type of capacitance which happens in forward biased condition. Usually the value of the diffusion capacitance is much higher than the transition capacitance. In forward bias, which carries forward current IF, when consider the diode is in a higher forward bias voltage and we suddenly reverse it to a reverse bias, so there are stored majority carriers available in the depletion region which has to come out. So because of this, a capacitance happens because of the discharging of the stored charge carriers. So CD, the diffusion capacitance, is equal to tau ID by eta Vt. Tau is the minority carrier lifetime. ID diode current, eta is semiconductor constant, 1 for germanium and 2 for silicon, and Vt equal to Kt by Q, which is T by 11,600 thermal voltage, and the value of diffusion capacitance is from 10 to 1000 picofarad. The diffusion capacitance happens in forward bias PN diode and transition capacitance happens in reverse bias PN diode, which are both used in some applications. So these are about capacitances in PN diode. Thank you.